Hello everyone and welcome to Learn with Edutechie. In my previous video, if you have watched it of course, we solved the climbing stairs problem using recursion technique, and then what we did, we optimized it back with the dynamic programming approach using a DP array, right? But here's a real interview question, right? This thing will actually make or break your interview. So in this video, we are going to take a look at the DP solution one step further, try to optimize the space complexity from O of n to O of 1 using just two variables while keeping the same logic intact. If you haven't watched my earlier video yet, I highly recommend checking it out first, and the link is going to be in the description. So let's get started. So this was our previous approach, right? What we saw during the recursion approach, that we actually, when we were trying to calculate how the number of ways to climb a particular number of stairs, we're actually keeping a track of the previous n minus 1th ways to climb that particular staircase and the previous n minus 2th way to climb that particular staircase. And that's the exact approach that we followed during the recursion technique, and then we optimized it using our DP approach. But in this approach, since we only have two states to take care at each point in time, we will not need to store the other states in our lookup or our cached array, right? So that makes sense, because let's try to understand. If you are trying to calculate the number of ways to climb 50, it doesn't depend on the number of ways to climb 47. Rather, it only depends upon the number of ways to climb 49 stairs and number of ways to climb 48 stairs, right? So it is just two states which it depends on. The current value depends on the previous two values. It doesn't depend on the other values. So we can simply remove this entire DP array. We can simply remove this entire DP array. And what we can do, instead of ways to climb 0, what we can write long. Why we are taking long? Because we do not want it to blow up for large integers, right? So we can say that this is our first previous ways to climb, which is 1, right? And this is nothing but, we can consider this as W of 0, which is number of ways to climb 0th staircase. Similar way, what we are going to do here is, we are going to take another variable, and this time we are going to call second previous ways, and this is also going to be 1, right? So this will be W of 1. Let's consider it as W1 of 1, or rather number of ways to climb one staircase, right? And now we start our loop from the second staircase when n is equals to 2, and then we go up till n, right? And here what we try to do, before that, we also have to keep track of the current number of ways that we are reaching the staircase, right? So this current will be initializing it back to 0, and here, instead of writing ways to climb I equals to ways to climb I minus 1 plus I minus 2, what we are going to write? We're going to write the current ways will be nothing but equal to the first previous ways plus your second previous ways. So imagine that this is our W2. So in the next case, what we need to do, we need to change our first previous ways. That means we need to change W of 0 to W of 1, which will become our second previous ways. And finally, what we have to change, we have to change our W of 1 to the current ways, which is nothing but W2, right? So this is it. That's it. And at the end, what we are going to return, we are going to return current ways from here. So now if I try to run the code, this code will still run extremely fast. And the best particular thing about this particular solution is that you don't need that cached array. So you're actually saving a lot of space in the memory, right? So imagine that this n is a large number. You don't need to store all these values, previous values, right, in this particular memoized array, because in this particular problem, you're just depending on the previous two states. The other states doesn't matter, right? So now if I run my code, I still should see the same exact answer, and you can see that we are getting that, and it's so fast, right? I hope you like this solution. So my final statement will be for all of you is that this is the way to optimize the climbing stairs you have seen. But the key takeaway is extremely simple, right? So whenever there is a dynamic programming solution, that will depend on only the previous two states. You do not need the entire DP array. You do not need the entire DP array, and only two variables which can keep track of the previous two states are more than enough. And this is the exact kind of optimization that interviewers are going to look for after you have, of course, after you have explained the basic recursion backtracking approach and the dynamic programming approach, right? If you haven't watched the earlier video where I have already broken down the entire recursion and backtracking tree and the entire approach using recursion and backtracking, as well as the entire dynamic programming approach, please make sure to check it out. The link will be present in the description. And if this video helped you, please subscribe, like my channel for more interview focused problem breakdowns. And I'm going to see you in the next one. Thank you so much.